Welcome Algebra 2, this is Mr. Ariano once again to present to you a world premiere on exponential functions. Just take a sip of my tea. Alright, well, let's go ahead and talk about exponential functions, and one of the ways that we're going to do this is by looking at a table. So, let's say that I told you that I wanted you to create an equation for this table right here. So you needed to create an equation for this table. Now, maybe one of the natural things to do is to make a linear equation, right? We have y is equal to mx plus b. If we try doing that equation, we know the b is our starting value. Well, that only happens when x is 0. So we have y is equal to mx plus 1. Now, if we wanted to find out what our slope is, basically the rate of change, what it's increasing by, we do 3 minus 1 to get 2, 9 minus 3 to get 6. Now, we run into a problem because in order for this to be linear, the first difference, every time I subtract these numbers, they have to be the same. But it's not. So right now, this is not linear. So, okay, this table can't be modeled by a linear equation, right? Think about this scenario here. You have a linear equation like this. Let's say 1 and then 1 to 3 and then 1 to 5 and then 2 to 5 and then 3 to 7. This would be a linear equation because 3 minus 1 is 2, 5 minus 3 is 2, and 7 minus 5 is 2. So it's increasing by 2 every time. So our slope is 2 and our y-intercept is here at 1. So the purple table that I have listed is not a linear equation. So we want to find out what it is. Well, this is actually going to be an exponential equation. If you notice, the pattern that this table has is it's multiplying by 3 every time, and it's really you could see it right here. What's 3 times 3? Well, that's 9. All right, what's 9 times 3? Well, 9 times 3 is 27. What's 27 times 3? Well, that's 81. And it even makes sense up here. What's 1 times 3? Well, 1 times 3 is 3. So the pattern for this is that it's multiplying by 3 every time. Now, if you one thing to notice is that if you have 3 to the first power, well, that's just going to equal the 3 that we have here. Then we have 3 squared. We're going to get the 9 here. 3 raised to the third power, we're going to get 27. And 3 raised to the fourth power is going to get us 81. Alright, and 3 to the 0, 3 raised to the 0 is going to give us 1. Because so if we look here, this is the pattern that we have. We're basically multiplying by 3 every time, or we're increasing the exponents. We're increasing our exponents by 1 every time, if you notice here. Alright, 3 to the 0 is 1, and 3 to the 1 is 3, 3 to the 3 squared is 9, 3 to the third is 27, and 3 to the fourth is 81. When we have something that's multiplying a table across, like you see right here, when we're multiplying by number, this is considered exponential. And the equation looks like this: a times b raised to the x, where a is our starting value, and b is our constant multiplier. It's the number that we're multiplying the table by every time. Alright, well, our starting value is 1. If you notice that right here. And then our constant multiplier is 3. That's the number that we're multiplying by across every time. And it makes sense because if I take 2, the x value 2, and plug it in for x, I'm going to get 3 squared. And so I'm going to get this equation that's going to model this table right here, and it's exponential because we're multiplying by a constant multiplier every time. That's what makes this an exponential function. This is just a quick introduction to exponential functions in case you were unsure of what exactly it meant.